At first glance, the universe seems unchanging. In the night sky, apart from the occasional comet streaking by, brief meteor showers, or a brilliant supernova explosion, everything appears relatively the same. But in reality, this is simply a matter of resolution for the naked eye. Without prior knowledge or forecasts, we wouldn't see the events unfolding in the universe, as they often hide in the vast darkness. Occasionally, we may witness unexpected changes, like the dimming of the star Betelgeuse a few years ago. However, observing the sky with such low resolution prevents us from noticing many changes we might expect to see. But telescopes can help change this. They open up a new world where we can witness stars varying in brightness or comets colliding with Jupiter. Remember back in the 90s, a comet left large dark spots on Jupiter's surface, spots that even small telescopes could detect. And not only that, but with stars that vary in brightness, we begin to see that the sky isn't as quiet as we once thought. These occurrences can all be explained. They're the normal changes that we can observe and predict based on current astronomical knowledge. But as scientists enhance the resolution of telescopes, we begin to discover strange new things, where sometimes objects seem to disappear from the sky in a perplexing way. And we have no idea why. Even after years, these phenomena remain unsolved puzzles or sometimes fall into obscurity. One example is the young star TYC 82412652. This star is similar to our Sun, a G-type star in the early stages of its life, located in the constellation Sagittarius. What's notable is that it's only around 10 million years old, a baby compared to the 4.6 billion-year-old Sun, and about 450 light-years away. The star was first detected in 1983 by the IRAS satellite, one of the first space telescopes to observe the entire sky in the infrared spectrum. When IRAS observed it, the star shone brightly in infrared, a normal characteristic for young stars like TYC 8241-2652, as they typically have a debris disk of gas and dust surrounding them. Young stars with such a debris disk often hold the potential for planetary formation. Our own Sun once had a similar disk from which the planets and asteroids of our solar system gradually formed. Over time, this process helps the star heat up the dust and gas in the debris disk, and we can see its warmth radiate into space as infrared light. For 25 years, TYC 8241-2652 appeared to maintain this debris disk in a stable state as scientists periodically observed it. But then, something strange happened. In 2010, when NASA's WISE spacecraft returned to observe it, the debris disk had suddenly vanished at certain infrared wavelengths. This was inconceivable, because the universe doesn't usually change that quickly. So what happened to make this massive debris disk disappear or alter within just a few short years? Scientists have proposed a few hypotheses, but none are truly convincing. One theory is that a major collision occurred on a forming planet, causing dust to quickly fall into the star. However, this explanation seems unlikely. Another hypothesis suggests that dust particles collided and were ground down to such tiny particles, smaller even than smoke, that they became undetectable. But this too shouldn't happen so fast. Some have even speculated about an automated system of von Neumann-style robots that could have cleared the debris disk. However, this idea is more speculative than a practical scientific explanation. One thing to note is that protoplanetary disks aren't just sites for planet formation. They're also filled with constant collisions. Imagine a vast population of asteroids and protoplanets colliding and releasing dust. But this process usually takes millions of years and helps to replenish dust in a system. This didn't happen with TYC 8241-2652. What happened to this star system remains an unresolved mystery. A more recent example involves the star HD139139, observed during the Kepler mission. Kepler was an advanced light measurement instrument, tracking stars to detect exoplanets by recording slight changes in brightness as planets pass in front of stars. With the Kepler mission, HD139139, a binary star system consisting of a G-type star and a red dwarf, displayed a remarkable sequence of events. The star experienced 28 instances of brightness dips during Kepler's observation, suggesting possible exoplanet transits. But oddly, these brightness dips had no periodicity, making it unlikely that this was an orbiting exoplanet system. After scientists observed the star again this year, no further dimming occurred. The mysterious brightness dips vanished without leaving a trace. Some scientists have suggested it could be a technical issue with Kepler, but this seems unconvincing as Kepler hadn't encountered such a problem before. Another theory is that foreground objects, such as rogue planets, may have moved in front of the star from our viewpoint. Similar cases have been found, but the planets in question are extragalactic, making detection even more challenging. The universe holds many surprises, such as the discovery of rogue planets near the quasar RxJ1131-1231, thanks to the gravitational lensing effect. This quasar, located 6 billion light-years away, is affected by a foreground galaxy that creates 4 images of the quasar. Remarkably, physicists from the University of Oklahoma leveraged this gravitational lens to detect a group of rogue planets within the quasar's interstellar space, ranging in size from the Moon to Jupiter, passing across the sky. But perhaps the strangest case is the discoveries from the Vasco Project. The Vasco Project searches for light sources that vanish or suddenly appear by comparing sky images over many years. They discovered hundreds of stars that seem to disappear without any clear reason. Stars can go supernova or dim, but it's rare for them to completely vanish. One hypothesis is that they might collapse directly into black holes without exploding. However, such silent collapses are extremely rare and unlikely to occur hundreds of times in a single century. Another possibility is gravitational lensing. The starlight might be temporarily obscured by an interstellar black hole, making the star disappear before the light source returns. But there's also a more audacious hypothesis. An alien civilization could be constructing a Dyson Sphere to surround and block the star's light, effectively making it disappear as a means of creating a limitless energy source. Could there be technologies we've never imagined? Just as technology evolved from hot air balloons to airplanes, with modern aviation now transporting thousands of people daily, a concept unimaginable a century ago. Who knows, there could be civilizations beyond our wildest imaginations. Throughout its history, the Milky Way has absorbed many smaller galaxies, but eventually, the Milky Way itself will be consumed by the giant Andromeda Galaxy. This universe is truly wondrous and constantly in motion, and we have only begun to scratch the surface of its endless mysteries.